All right, this lesson is on absolute value. Before we actually discuss the absolute value problems, how to solve them, it's important that you understand what absolute value actually is. A lot of students, they misinterpret absolute value as just making whatever that value inside the number inside the absolute value bars, just making it positive. But the reason why that number is positive is because the absolute value represents the distance that number is from zero. So if we have a number line, we've got two numbers that are 2 units away from zero. Positive 2 is 2 units from zero, as well as negative 2. So the absolute value of negative 2 is the same thing as the absolute value of positive 2, since they're both 2 units from zero. All right, the quantity inside the absolute value bars, it always has a positive and a negative value. Now the result is always going to be positive since it's a distance, but whenever you see those absolute value bars, there's a value inside of the absolute value bars that is both positive and negative. So if we have the absolute value of x equals 3, we're looking for two numbers that are 3 units away from zero. Those two numbers would be negative 3 and positive 3. Both of those numbers are 3 units from zero. Now if we had something like this, absolute value of x equals negative 4, that doesn't make sense because, like we said earlier, absolute value represents the distance from zero. And you can never have a negative distance. There's no such thing as having a negative distance. So there's no solution to this problem. All right, first example. To solve absolute value equations, what we want to first do is isolate the absolute value bars and everything that's inside of them. So the way that we would do that for this problem is we would subtract 7 from both sides. Now we've got the absolute value of 7 plus 7n equals 21. Now I want to set up two different equations since there's two solutions. All right, so I'm going to set up an equation where I have a positive value for the expression inside the absolute value bars and one where there's a negative expression inside the absolute value bars. So let's solve the positive one first. We want to start by subtracting 7 from both sides. Then we get 7n equals 14. When we solve for n, we get n equals 2. That's one of our values for n. Now when we solve the equation on the right side, what I usually do is I go ahead and get rid of the negative first by dividing both sides by negative 1. When I do that, I'll get 7 plus 7n equals negative 21. Subtract 7 from both sides, get 7n equals negative 28. Divide both sides by 7. N equals negative 4. So my two solutions to this absolute value equation is n equals negative 4 and 2. When you're entering your answers, enter the smaller answer first and then the bigger number separated by a comma. Don't put parentheses around it because it's not a coordinate. We're just using a comma to separate the solutions to this equation. So negative 4, comma 2. All right, next, again, we want to isolate the absolute value bars by subtracting 10 from both sides. When we do that, we'll get negative absolute value of 6v plus 1 equals negative 1. And then again, I want just the absolute value bars isolated on one side, so I just want the positive absolute value bars. So I'm going to divide both sides by negative 1. When I do that, I get the absolute value of 6v plus 1 equals 1. And then I'm going to write my two equations, one where the quantity inside the absolute value bars is positive and one where the quantity is negative. I solve the positive one first by subtracting 1 from both sides. I get 6v equals 0. Divide both sides by 6. V equals 0. So that's one of my solutions. And then solving the equation for the negative quantity inside the absolute value bars. We're going to divide both sides by negative 1. I'll get 6v plus 1 equals negative 1. And then subtract 1 from both sides. You get 6v equals negative 2. Divide both sides by 6. V equals negative 1/3. And again, write your solutions, the smallest number first, and then separate the two solutions with a comma. So negative 1/3, comma, 0. All right, next, we want to, again, isolate the absolute value bars. In this case, we want to subtract 3 from both sides. To do that, we'll get the absolute value of 3 plus 5m equals negative 27. And you should be alerted by that negative 27 because you cannot have a negative distance. So, since you cannot have a negative distance, there's no solution to this problem. All right, anytime you have absolute value bars on one side of the equation, the number on the other side of the equation should be positive. All right, next we've got a couple absolute value inequalities. Same steps, except we're going to also graph the solutions for these, and the graphs will help us to actually write out what the interval of solutions are. All right, so just remember, whenever you're dividing or multiplying both sides by a negative number, you have to change the direction of the inequality. So we're going to start by dividing both sides by -4. When we do that, it's going to change the direction of the inequality to a greater than symbol. And then we're still going to write both inequalities now, the one that has a positive value for the quantity inside the absolute value bars and one for the negative quantity inside the absolute value bars. We solve the positive one first. We get negative, we subtract 6 from both sides, get negative n is greater than 5. Then we have to divide both sides by -1, which is going to change the direction of our inequality. We get n is less than -5. For the negative quantity, we want to start by dividing both sides by -1, which is going to change the direction of the inequality. And then we will subtract 6 from both sides. We'll have negative n is less than -17. And then last step, divide both sides by -1, which is going to, again, change the direction of the inequality. And we should get n is greater than 17. So if we go ahead and graph that, there should be an open circle at -5, since there's no bar under that inequality. There should also be an open circle at 17, since there's no bar under that inequality. And for the n is less than -5, the arrow is pointing to the left, so our arrow should point to the left also. For n is greater than 17, again, an open circle, and that arrow is pointing to the right, so our arrow should be pointing to the right. Now, to actually write out the solution, you guys just write your solutions using interval notation. If we start with that first, the left part of that graph is going to -infinity. So anytime you have infinity, you have a parenthesis next to infinity since it's not a finite number. So we have parenthesis, -infinity, and that piece of the interval goes all the way up to -5. And we're not including -5, so there should be a parenthesis next to -5, and then a union symbol to connect the two, combine the two graphs, and then open circle at 17, so parenthesis 17, and that one goes to positive infinity, parenthesis. And the last example, we want to start by adding 8 to both sides. After we've added 8 to both sides, we'll get -5 on the right side. Then we want to divide both sides by -1. When we do that, it's going to change the direction of the inequality, and we'll have the absolute value of 5 minus 9v is less than or equal to 5. Write our two inequalities, one with the positive quantity inside the absolute value bars and one with the negative quantity. Solve the positive one by subtracting 5 from both sides. Get -9v is less than or equal to 0. Divide both sides by -9. And that's going to change the direction of the inequality to give us v is greater than or equal to 0. And start by dividing both sides of the second inequality by -1. It's going to change the direction of the inequality, giving us 5 minus 9v is greater than or equal to -5. Subtract 5 from both sides, we get negative 9v is greater than or equal to negative 10. And then divide both sides by negative 9, which is going to change the direction of the inequality again, giving us v is less than or equal to 10 over 9. Again, graph it. We should have closed circles at 0 and at 10 over 9. And for our inequality on the left, the v is greater than or equal to 0. That arrow is going to be pointing to the right. And then for the v is less than or equal to 10 over 9, that arrow is pointing to the left. For and compound inequalities, the solution is the intersection of those two graphs, where those two graphs overlap, which is all the space in between 10 over 9 and 0. So that's our solution. To write the solution using interval notation, we want a square bracket next to 0, and then that interval will go to 10 over 9, and a square bracket after 10 over 9.